Okay, so today our learning intention is still working on trigonometry like you did yesterday. However, we're going to be now actually doing some calculations and finding the side lengths of our triangles. So you will need your scientific calculators to work these out, and there's a couple of buttons I'm going to introduce you to. Now, before we even get started on using our calculators, you need to make sure it's on degrees mode. Now, often on your calculator screen, you would see a D there, or you might see an R, or you might see a G. Now, obviously, we want to see the D on your screen. If you can't see the D on your screen, often if you just click the reset button at the back of your calculator, it should automatically reset it to degrees mode. There is a way using a button on there as well. It's normally somewhere towards the middle of your calculator, the DRG button. So if you locate the DRG button, press that and it will change the letter in the top of your screen to be either degrees, radians or gradients, but we want degrees mode. In a test situation, if it's not in degrees mode, there's a high chance that you will actually get the wrong calculation and therefore write down the wrong answer. So with trigonometry, finding the side lengths, writing down your working out is actually really important, because at least you'll get one of the marks out of the two potential marks if you knew the calculation wrong. So that's probably something to be aware of. The other buttons you need to be able to locate are the sine button, the cos button, and the tan button. Those are our ratios. Sine, cos, and tan are ratio numbers, kind of like your pi button, okay? So there's a number behind it that makes it work for the right angle triangle. So those buttons, make sure that you know where those are. Now, this kind of talks about it in our key ideas here with a couple of examples, but I think I'm going to go through straight to our examples to do it with you. So make sure you've got your calculator handy now. So step 1, example number 8, is simply getting you to use your calculator. All I'm going to ask you is you press the sine button, 5, 0, and then the equals. Your calculator does all the work for you. Now, they want this answer correct to 2 decimal places, and most of the time when we do in trigonometry, we want it to 2 decimal places. But always just double check that so that you don't get it wrong. The answer you should get is 0.77. Make sure that you got that same answer. If you didn't, have a look at your partner and see that they got the same answer as you or different, and see what you've done potentially incorrect on your calculator. Remember, it needs to be on degrees mode. All right, for B, same thing. You now press the cos button. 1, 6, and equals. So cos 16 degrees is what we're calculating, and the answer you should get is 0.96. Brilliant. C's the same, except now we're pressing the tan button. So tan 77 equals, and the answer you should get to 2 decimal places is 4.33. Brilliant. Hopefully you got that with ease and using your calculator. That's half the hard bit, is making sure you know how to use that. And now we can actually move forward into actually doing a proper calculation with a right angle triangle. All right, example number 9, good old solving equations. Similar thing, we need to find the value for x. So by doing that, we need to get it on its own, and then they want the answer to 2 decimal places. So the calculation we're working with is cos 20 is equal to x over 3. Now, remembering back to solving equations, we want to get x on its own. Get used to seeing the x on the right-hand side, especially with trigonometry. That's normally where we end up leaving it. We're not going to touch the x, but we are going to look at that division of 3. We're going to times both sides by 3. So we now end up with cos 20 times 3 is equal to x. All right. Now, if you've got the recommended calculator that was on the book list, this next part's probably going to be a lot easier than if you don't, because if you don't, you might get a bracket. Press cos And if a bracket appears, okay, you need to make sure you close the bracket after the 20. So if a bracket opens, don't put it in if it doesn't, but if a bracket opens, after the 20, you need to close that bracket and then do the timesing of 3 and press equals. If you don't have a bracket, a lot easier, you just need to go cos 20 times 3 and press equals. Does all of it for you. Okay, so make sure you know which one your calculator does, bracket or no bracket, and that will be important for when you do your test. So, what does x equal? In this situation, x to 2 decimal places is 2.82. Brilliant. So there's a little refresher on solving equations. Moving on down to the next page, on page number 16. These are your more classic type of questions. This is probably what you're going to see more of in your test. This is now applying what you had to do yesterday. Label your triangle first. So they're asking us to find the value of x correct to 2 decimal places. Opposite the right angle is the hypotenuse. So that 7 is the hypotenuse. 38 is where we would have had our theta. So we actually now know what the angle is, 38 degrees. So the x is my opposite, and this last line is the adjacent. It's next to my 38 degrees. So like we did yesterday, so, ka, toa. Notice the A side has 0 information. There's no letter, there's no number. So anything with an A is going to be completely useless to you. You can't use it. So any rule that has an A in it, you cross out. So that leaves me with sine theta is equal to opposite over hypotenuse, and that's what you were practicing yesterday. Now I can fill in the information. We know that theta is 38 degrees because they told us that in the diagram. The opposite side is x, and my hypotenuse is 7. Fantastic. Solve for x. Want to get x on its own, so it's going to be sine 38 times 7 equals x. Know how you use your calculator like I explained above. Do the calculation, and the answer for x should be 4.31 because they want it to 2 decimal places is equal to x. You get 1 mark for your working out and 1 mark for the answer, normally 2 marks for these type of questions. Great. So for B, back to your diagram, label it. Opposite the right angle, that's my hypotenuse. 42 degrees is where my theta is. So the x is now my opposite side and the 4 is my adjacent. So, ka, toa. Notice that the side now that has no information on it is the hypotenuse. So there's no x or y or z or whatever, there's no number. So anything with h in it is useless to you. So today I'm going to be using tan theta is equal to opposite over adjacent for diagram B. Theta, which is the angle, is 42 degrees. Opposite side is x, the adjacent side is 4. Solving for x again, so it's tan 42 times by 4 is equal to x. Punch that into your calculator, knowing how your calculator works. It's going to be 3.60, which is equal to 2 decimal places, and that's what my x equals for B. Same thing, 2 marks for that. All right, back to question C. Last question for today. Opposite the right angle is your hypotenuse, so that's where my 10 is. 24 degrees is there. The opposite side is there. And the adjacent side to 24 is my x. So, ka, toa. Notice there's nothing for your opposite side, no letter or number, so anything with an O in it is useless to you, so therefore you get left with cos theta is equal to adjacent over hypotenuse. Cos 24 degrees is equal to x over 10. Cos 24 times 10 is equal to x. Know how you use your calculator. Type that in, and the answer you should get to 2 decimal places is 9.14 is equal to x. Fabulous. 2 marks. Working out, so I'm expecting working out to be shown for your classwork today, and obviously the answer, make sure you round it correctly and mark the questions as you go. And that is the start of making your calculations for trigonometry and their ratios. If you have any questions, please feel free to email me and we can go from there. All the best.